Now on to the last bit on deceptions and visual displays of data. Benjamin Disraeli, the Queen Victoria's Prime Minister, stated that there are lies, damn lies, and statistics. Now, the problem isn't that statistics actually lies, but it's rather liars use statistics to get what they want out of them. So graphs can be used to distort the underlying data, making it difficult for the viewer to learn the truth. One potential source of misunderstanding is the scale on the vertical axis used to draw the graph. This scale is important because it lets researcher inflate or deflate a trend. For example, both graphs in Figure 12.7 represent identical data for the percentage of people in the United States living below the poverty level between 2015 and 19. Now, the graph on the left stretches the scale on the vertical axis to create an overall impression of poverty rate decreasing rapidly over time. Now, the graph on the right compresses the scale on the vertical axis to create an impression of poverty rate that is slowly decreasing over time. So you can see here on the left, it looks like it's really going down fast. And here it looks like it's barely moving at all. And in fact, it's probably closer to this one here because it's, 13 down to 10%. So it's not a lot. So it's 3% decrease. And so it's probably more in a line along this one, but it's slowly decreasing, but it depends on, how you want to look at it as far as it goes. It's the key is how does it do it? Now notice on both of these, it has that thing we talked about earlier where we don't have to draw all the numbers from 0 to 6 or 0 to 10, and that makes it so you don't have to have such a big graph because otherwise it would be a lot taller, and then you would have it coming down like this, and then most likely that would be more of a real graph when you did it that way. All right, so now there's another problem with the data in Figure 12.7. If we look at figure or table 12.5 here, it shows the poverty rate from 2001 all the way to 2019. Now, depending on the time frame chosen, the data can be interpreted in various ways. So choosing that time frame also helps represent data trends in the most positive or most negative light. So if we think about here, what do we have? Well, if we look from here down to, say about, well, if we even go to 2012, if we only went to 2010, it'd be, only increasing. But this one, it just goes down a little bit. But overall, it increases in that part of the period. Now, and if we go from here all the way down here, then that's when we get the decreasing. So really, it's what it's doing is it's going up and then it's coming back down again. Now it goes down further than it started, so it comes down a little further than where we started at. But that's kind of the overall trend is it's kind of a parabolic shape here. Now, things you need to watch for in visual displays of data. So, is there a title that actually explains what's being displayed? A lot of times they leave that out and it leaves you to make up what's being displayed, and that is another trick. Consider axis fraud. Are the numbers lined up with tick marks on the vertical axis that clearly indicate the scale? And has the scale been varied to create a more or less dramatic impression that is shown than actual data? Three, do too many design and cosmetic effects draw attention away from or distort the data? Four, has that wrong impression been created about how the data are changing because equally spaced time intervals are not used on the horizontal axis? And we can see that what happens is they go from here to here and then here to here, and then the next one, it should be something like that, but they still say it's from here to here. So it really should be a long one. It might be a 5 years, and then this is a 10-year frame, but they put it in and say, well, that was actually not 5, that's 10 in this case. And so that's kind of what they mean by that. Now, furthermore, has the time interval been chosen that allows the data to be interpreted in various ways? Number five, are bar sizes scaled proportionally in terms of the data that I represent? So they're just making bars at different sizes. We'll look at something about that in a little bit. And is there a source that indicates where the data in the display comes from? So did the data come from an entire population or a sample? Was it a random sample used? And if so, are there possible differences between what is displayed on the graph and what's occurring in the entire population? And who is presenting the visual display? And what does the person have a special case to make for or against the trend shown on the graph? So there's a lot of things. So, like news channels, one will be, pushing everything Republican, and so it'll put displays one way. The other one will be over here. They'll be doing things more Democrat way, and so they'll represent the same data different ways. And so you can see that depending on which channel you watch, you'll see different versions of how that source is being used. So we'll go into a couple of the graphic displays on what we see here. And one, the first one is looking at the purchasing power of the diminishing dollar. Okay, so they do give us a source, and so it's 50 cents, a dollar, and so the scale, it looks reasonable, but now all of a sudden the widths are kind of weird. So although the length of each dollar bill is proportional to its spinning power, the visual display varies both the length and the width. So if we'd have kept the width the same, it wouldn't be a problem, but they're changing both. Now, because our eyes focus on the areas of the dollar shaped bars, so now we're not just looking at the height, we're looking at how far is it this way by how far it's this way. So the length times width, well, that length times width, it's much greater than that one, even though that this is should only be 63% of this one. It's a lot smaller because we've diminished the width of the bar here. All right. So, continuing on, you can read a little bit more about that. But another potential problem with this graph is the selection of the specific years to be included on the horizontal axis. There's a gap of 10 years between 1980 and 1990. Like I was telling you before, sometimes they put bigger gaps in the years. And then only 5 years between 90 and 95 and between 95 and 2000. And then there's a whopping 20 years between 2000 and 2020. So, these are not all the same 5 year things or all the same 10 or even all the same 20. They're varying as you go across. So that's another a big way that people can change and make visually looking like it's not worth as much as it should be. Okay. So we really need to question whether these years were chosen intentionally to create the illusion of a trend, and also whether that trend would be still evident if different years were included in the graph. So what if we did, 1980, 85, 90, 95, 2000, 2005, 10, 15, and then 20? How would it look then? So that's really a key thing is thinking about how that would change what we see here in the graph. And the kind of the last thing I want to leave you with is the number of square feet in an average U.S. single family home. So we're looking at it now, we're comparing homes, and obviously they want to say that, this one's bigger here versus back here, but now we're changing shapes. You can see the graphs as far as, the shadows, those are different sizes. So we're doing all kinds of different things to tell the proportionalities, how they're different. And really, what we really want to do is we want to look at those numbers here. So that's kind of the key thing. Now, again, so we're going 80, 90, 2000 would be the next one, then 2010, then 2020. So, we're not going by even units on our years. So that's another thing to increase. So, there was a greater increase from 1980 through 1990 than from 1990 through 2020. So, that's kind of a thing to think about there too. So, if you look at it, the square feet per year change. So, it's a lot of different things you need to look at when you're looking at graphs. Some other things that you might notice, if you look at pie charts, they'll have in some news things. And when you do it, it should add up to 360 degrees or 360 whenever you're doing it as far as each of the slices. But what happens is if you actually add it up, sometimes it'll be up to 400 or it only might be a 30. And so the numbers don't add up to what they should be. So there's another thing you need to think about when you're looking at these. Do the graphs make sense based on, mathematical things? So I'll leave you with that and hopefully that helps you with this section.